And when we fill it up, we're filling it up to the lines on both sides, right? We have our water that we got from the Gator enclosure. We're going to fill it up both sides to the line, keeping conscious that we have a meniscus. Anybody know what a meniscus is? Yep, it's the natural curvature of water when you put it into a container. So we have that. What I want you to do, the first thing we're going to do is we're going to test for our free chlorine, and we're going to test for pH, being that we filled both vials. The yellow bottles are for chlorine. They should be in order, but double check my instructions. The red bottles are for pH. So I want you to take that first yellow bottle, and we're going to add 5 drops of that to the smaller vial. So take the cap off, and that should be DPD number 1, correct? Mm-hmm. Okay, so 5 drops. I want you to hold the bottle perfectly straight up and down. Perfect, there you go. 1 drop at a time for a total of 5. You can do it a little faster than that. You can give it a squeeze. 5 drops. There you go. Put the cap back on, put the bottle away. Now we're going to take the second yellow bottle, which should be DPD number 2, correct? We're going to add 5 drops of that to the same vial in the same exact manner. 5 drops. Okay. Now, because we filled both vials, I want you to take the first red bottle, which should be R0004. And everybody, what's the name of the chemical in that one?
Phenol red.
Phenol red. And it's easy to remember because it starts with pH. And what sound does that make? Awesome. 5 drops of that now into the larger vial. Perfect. Put the cap back on. Put it back into the test block. Take the cap for the test block itself. Put it on. Invert it slowly once or twice. We're not going to shake the daylights out of it because we don't want to create a lot of turbulence in there, because if we create turbulence, that can actually increase the pH. Now what I want you to do is take the test block with the numbers facing you, and I want you to hold it to the lights of the northern horizon.
In the sky,
Eye level, though. Eye level. Has to be your eye level. A little lower. There you go. And I want you to match these colors to the best of your ability. Now, this is chlorine and bromine. It's chlorine on the left, bromine on the right. I only want chlorine. So on the chlorine side, what's my color match?
1, 2.
Okay, so we're going to call it 1.0. If it was bromine, it was 2. So we're at 1 part per million for chlorine. And my pH then?
It's going to be 7.6.
7.6. So 1 part per million for chlorine, 7.6 for pH, which is good. Now what I want you to do is take that third yellow bottle. The third yellow bottle is the bottle that we use to determine whether or not we need to shock the pool. The third yellow bottle will give us our total chlorine rating. DPD 1 and 2 gave us our free chlorine rating. Anytime the total chlorine is higher than the free chlorine, that means that we need to shock the pool. That third yellow bottle is very easy to find in your test kits because it's the one that's still full. Right? 5 drops of that into the smaller vial. Okay, awesome. Put the cap on, invert it just like before. We're going to hold it up again to the lights. Where? What lights? The northern horizon. At eye level, the South Georgia lights. All right, and we're going to match the color once again, a little bit lower. I don't think you're as tall as you think you are. All right. And we're going to match up the color to the best of our ability, and this time we come up with what? The same thing. The same thing in a Gator enclosure. You guys are killing it. No combined chlorine level. 1 part per million free chlorine, 1 part per million total chlorine. The difference between the two would be the combined chlorine level. If there's no difference, that means we don't need to shock the pool. You only need to shock the pool when the total chlorine is higher than the free chlorine. Nicely done. All right, we're going to dump that out. Now what I need you to do is rinse the vials again, and we're going to test our total alkalinity. Where does that go? That's fine. That's fine.
we don't do it like that.
All right.
Just a regular drink.
Rinse it out.
Maybe on the test, but we don't.
We're going to rinse it again. We're going to test our total alkalinity. So I want you to put the cap on, shake it up, dump it out.
We don't lose it either. I've never used it.
All right, now this vial, the larger vial, I want you to fill up to this line, the 25 milliliter mark, and there's a little bit of a trick to it. So if you overfill it, go ahead and overfill it intentionally. I want to show you something. Keep going, keep going, keep going. So one of the easy ways to get a level in this one is just to simply take it. It's going to be hard to do backwards, but hold on a second. Just to take it and tilt it until that bubble hits the very, very base of the kit. Let's see if you can do it backwards. There you go. And that should bring you exactly to the 25 milliliter mark. So that's a quick way that you can go about that. Now, green bottles. We're dealing with green bottles. That type of test you did a moment ago where you hold it up and match the colors, that type of test is known as a colorimetric test. If you break the word apart, it's just simply colorimetric. This one's going to be a titration test. We're going to add drops to make a color change. So take that first green bottle, R0007. That's a chlorine neutralizer. We're going to put 2 drops in, and then we're going to give it a good swirl. We don't even need the cap anymore. Just add your 2 drops. Again, straight up and down, nicely done. Give it a good swirl. Each one of those drops will neutralize 2.5 parts per million of chlorine if it's in the water. So we've just neutralized that test high enough to test our total alkalinity if our chlorine level is not greater than 5. Take the second green bottle. That's your total alkalinity indicator, R0008. We're going to add 5 drops of that and give it a swirl. If there is any total alkalinity in this water, the solution will turn green when he adds the drops. If there is no total alkalinity, the solution will turn salmon pink. So we see green, give it a good swirl. Easier to swirl from the top, but that's cool. There you go. All right, so we got the green color. Now we're going to take that third green bottle, reagent R0009. The chemical in that one is sulfuric acid. We're going to add 1 drop at a time until the solution turns from green to that salmon pink, indicating that we've brought the pH to a point low enough that total alkalinity ceases to exist. 1 drop, swirl in between each drop. I need you to count how many drops it takes to make this happen. 1 drop. 2 drops. You can add them a little faster. 3. Hold them straight up. Remember, the drops straight up and down. You can add the drops while you're swirling if you're coordinated enough. Depends on how well you're coordinated. Yeah. 4. Keep them going. Keep it going. 5. Nicely done. Keep going. Look, we're starting to get something. 6. Come on. 7. 8. Come on, keep going. Come on, come on. Oh, we're almost there. 9. Come on, come on, come on. 9 drops. 10 drops. All right, add 1 more drop to see if the color gets any more pink. If it doesn't, we won't count it. It certainly did, didn't it? 11 drops. 11 drops. All right, so what's my total alkalinity here?
110.
110. Each drop is worth 10 parts per million. So we're looking at a free chlorine level of 1 part per million. Combined chlorine 0. pH is 7.6. Total alkalinity 110. You guys are crushing it. Seriously. All right. Let's test the let's test the water hardness now, the calcium hardness. So we're going to dump that out. Now we're going to use blue bottles. Same level as the total alkalinity test. We want to bring it up to that 25 milliliter mark. So again, we're going to rinse it out slightly. All right. Fill it up again to that center line. Remember how I showed you how you can do that nice and easy? Unless you can hit it like that, that's fine. A little bit high. Using my trick. Kaboom. Perfect. All right. Now we're going to take the blue bottles. The first bottle is R01 or 0010. It's your calcium buffer. We're going to add 20 drops of that one. 20 drops. The reason we're adding 20 drops of this one so much, this first step, is what we're going to do is eliminate the effect of magnesium on our test. Because we don't want to test total hardness. Total hardness would be both the measure of calcium hardness and magnesium hardness. We don't want total hardness. All we want is calcium hardness. So what we're doing here is we're actually skyrocketing the pH to eliminate the effect of magnesium. Now we're going to take our second blue bottle, which should be our calcium hardness, our calcium indicator. We're going to add 5 drops of that and give it a swirl. Give it a good swirl. There we go. You see that purple color we got there? We're going to take that third blue bottle now. We're going to add 1 drop at a time, just like we did before. The goal here is to go from purple to blue. If you run out, you run out, and we'll just call it a day. This one uses a lot of drops, so.
Yeah, there's only a couple.
Hey, I may not be perfect, despite what I say online.
See if I got some.
I'll tell you what, considering there's about 40 gators in there, this water is in better shape than a lot of swimming pools that I've seen. As far as the chemistry goes, that's insane. I mean, were you expecting that?
I thought
Nope.
not really. It would be a
I would be proud. Yeah.
Yeah, I thought it'd be a hot mess.
No, so far. That's all right. I have another test we're going to do, and we're going to see how it holds up. We're going to test the Gator pool for phosphates. I know we're nailing it on. Yes, Annette, this is water from the Gator enclosure. Absolutely. How many drops?
It's 11 there.
11 drops. What's the drops worth on this one? Also 10. So 110 parts per million for calcium hardness. But take a look. I don't know if you guys can see. Oops. Oh, see the specks floating around? I can't do this with my finger here. If you can see the specks floating around in there, that's an indication that we have magnesium hydroxide in the water. So with magnesium hydroxide, it doesn't really affect the end result of the test, those little purple specks that showed up. But it does tell me that if the pH should spike, there may be a precipitant. I don't know that I'd ever notice it in here, but their pH is spot on the money. So nicely done. All right, so let's get rid of that one. Now we're going to run a phosphate test because, all right, so they've hit all the marks. The calcium hardness is a little bit low in the Gator test. But outside of that, this water chemistry has been really, really perfect, right? Again, chlorine level of 1.0. Combined chlorine with 40 gators in it, zero parts per million. pH at 7.6. My total alkalinity was 110. Calcium hardness is 110. Might be fine for a Gator enclosure. Not what we look for in a pool as far as the calcium hardness, but everything else is spot on. Now we're going to test for phosphates. So what I want you to do here is I want you to take one of these vials out of the phosphate kit. Okay, and rinse that out the same way. And again, this is the Gator water we're using. We're going to test Gator water for phosphates. This is our final test for today. And he shakes it up. And he dumps it out. To the line you assume, correctly. Yes. I'm going to dump these things out of here to make it a little bit easier here. Okay. And I want you to take one of these packets here. We're going to tear it and we're going to pour it into that vial. Conducting our phosphate test at the Gator enclosure. We got it. We did good, but thank you.
You got it?
Yeah, thank you. I appreciate it. Okay, so he's going to pour it in, pouring it into the vial. Okay, we're going to shake it up and let it set for a minute. Meanwhile, I don't know if... 60 seconds, let it set. That's the water we're testing. I did cheat and get the water sample from the pump room if anybody's looking at this. Okay. And what we're going to do is we're going to place this on one of these spots. Dale, we're going to take that vial and we're going to set it on one of these spots, take the cap off, and we're going to look straight down into it, and we want to match the color. And I'm going to put you in charge of that. So I don't know how well we can see in here from here. Oops. We do have a little bit of a phosphate level. We can see that. Dale, you want to match the color for me?
It's going to be closer to 1,000.
1,000 parts per billion of phosphates. This water looks pretty damn good. They're doing a fabulous job here. Can you imagine how hard that must be? Again, with our friends out there, pooping and peeing all over the place. I guess nobody's on any of the rocks anymore. Anyway, there you go. That's our water test for today.